Okay, here we are in a new video, and what it's all about is what we see on the left hand side of my computer screen. We see a unit circle here with a curious looking triangle in here, and what this video is going to be about is why these color-coded segments are labeled and color-coded the way you see them. It appears, I'll make a comment about it, it appears like this is cosine of theta quantity squared added to sine of theta quantity squared. Well, that's a trigonometric identity. Because the length of this hypotenuse is 1, then these two things add up to a quantity of 1. Okay, so we saw this in the last video from a Pythagorean point of view. Now we're going to see how Pythagorean theorem applied to a triangle with sine on one side, cosine, and sine on one side, cosine on the other side can be represented by the Pythagorean theorem. If you look at on the face value, apply Pythagorean theorem to the red, black, and green, blue sides, it says this side squared plus this side squared add together to give you a constant of 1. Well, if you take a look at this slider, that's exactly what's going on. So what we're going to do is we're going to see how this works. How come these things can be labeled the way you see them? Anyway, I'm going to go to a full screen over here, and we're going to see that. It's pretty exciting. So, okay, so I'm going to draw a triangle here with the unit hypotenuse, and this side is measured with respect to a unit hypotenuse. And I'm going to write down that I'm going to choose to put my angle arbitrarily in this side over here. I could have put it over here, but I'm going to choose to put it there. Now, in trigonometry, it says the side that's opposite from this angle, it's always called the opposite side. I'm going to call it opposite LG. There'll be a reason for that. I'll show you. You'll see that in a minute. I'm going to write down the definition of the sine of theta. Now, this is a definition of the sine of theta. I'm going to do something very unorthodox. I'm going to treat this as if it were an equation, and I'm going to solve for the opposite side. Equals sine of theta times whatever the hypotenuse is. Well, the hypotenuse for the large triangle is 1. So the way we calculate the length of this is the sine of theta multiplied times the hypotenuse, which is, in this case, 1. So sine of theta being equal symbolic values, I can use either one of these to represent the line, the length of this line segment, or the distance between these two reference points. So that's the reason why we can put sine there. Okay, so treating this side over here the same way, I'm going to call it the adjacent side, because in trigonometry is defined to be the side adjacent to our angle, wherever we have put our angle. So I'm going to write down the definition of cosine. And I'm going to put LG for large times divided by the hypotenuse sub LG. So I'm going to simply solve this for adjacent. Adjacent sub large is equal to simply take the cosine of theta and multiply it times whatever the hypotenuse is. In this case, it's 1. Okay, so cosine of theta being in adjacent sub large being equivalent, we can use either symbology for this side. So adjacent large equals cosine theta. That's the reason why we can use the symbol cosine of theta on this side to represent the symbolic value or symbolic distance between these two line segments with respect to a unit hypotenuse. That's something to keep track of and keep in mind. Sine and cosine are always measured with respect to a unit hypotenuse. So if we treat this as a base of this triangle, an altitude to it would simply be this line segment here at a right degree angle, and this being theta, this would be 90 minus theta, and this would be theta, and this would be we could label this as, if we wanted to put a symbol over here for this, there's no symbol so far, we could invent a symbol. So I'm going to say it's the opposite sub small s for small, and I'm gonna represent that this is the hypotenuse of this smaller triangle. You can see that it's opposite the 90 degree angle. So I'm going to give this some symbolism here. Just I'm going to call it the hypotenuse sub s for small. Okay, so I'm gonna use this equation again. So opposite sub small, it can be calculated by sine of theta times the hypotenuse sub small. So let's just fill in the value here. Hypotenuse sub small has a symbolic value of sine of theta times the sine of theta is sine of theta quantity squared. So this symbolism and this symbolism being the same, that's the reason why I can write sine of theta quantity squared for the length of that line segment. Oh my, we're out of focus. What did I do? Let me see if I can focus real quick. Oh, please focus. Okay. Now I don't understand why we lost our focus. Oh, because I don't have a focus lock. Okay, moving on. I only have 10 minutes, so I have to hurry. Sorry. In this medium-sized triangle right here, we have a large triangle, small triangle, and a medium-sized triangle. So I'll represent that this side right here is the adjacent side to our angle in this medium-sized triangle. And I'll give it some. I'll invent a symbolic value for it. I'll call it the adjacent side, AD DJ medium. And for this medium-sized triangle, you can see that here's the right angle. So across from it is the hypotenuse for the medium-sized triangle. So I'll label it HYP medium, MED for medium. Okay, so putting these values into this equation, using this equation again, I'm going to calculate ADJ medium. And that's simply the cosine of theta times the length of the hypotenuse medium. The hypotenuse for the medium-sized triangle. Okay, so we can see that the hypotenuse for the medium-sized triangle is this line segment, and the symbology for its length is cosine of theta. So we've just substituted in. You can see now that when you multiply cosine times cosine, you get cosine squared theta, cosine of theta squared, quantity squared. So this symbolism and this symbolism being the same, we can substitute either one of these in for this for that value. So I can write, that's the reason why I can write cosine squared theta. So here you see why cosine squared theta plus sine squared theta equals 1. Anyway, that's the end of this video, and please like it. It's always appreciated if you like. I'm going to go get out of this full screen, and I'm going to 10 minutes exactly. Please like and please subscribe.